Hello developers, I hope you are doing well. Welcome to the day 1 of the 30 days of JavaScript challenge. Over the next month, we'll be tackling daily coding challenges and delving into key JavaScript concepts along the way. Let's dive in and make the most out of this learning journey. Today's challenge says create a function, create hello world. It should return a new function that always returns the string hello world. So that is today's challenge. You're supposed to create a function that returns another function that returns hello world as the output. So there's some examples here. The first example, it says that when there are no arguments put in that function, it should return hello world. And that there's this explanation here. It says that the function returned by that should always return hello world. Then the other example is saying that if there are 3 arguments, it should also return hello world. So regardless the number of arguments that are passed to the function, it should always return hello world. And you can see here is the constraints that the arguments, the length of the argument should be between 0 and 10. So without much ado, let's learn about some key concepts that we can use to solve this challenge. So the first concept that we'll learn is to create a function. So basically there are 2 ways of creating a function in JavaScript. The first way is the basic function syntax, and we'll just write it out. So that is, you just write the function keyword, then the name of the function. Like let's just create a function of adding 2 numbers, so I'll call it add 2 numbers, like that. Then you put your parameters. I'll just put a and b. Then here is the function body, where you put the logic of your function. What you want the function to do, you write it inside there. So mine is to add 2 numbers first. I'll create a variable, I'll call it sum. Then I'll return the value of a plus b. I'll store it in that variable. Then I'll return the sum, like that. So here I've created a function called add 2 numbers using the basic JavaScript syntax, and that is using this function keyword. Then I put my 2 parameters there. Then this is the function body, the logic of my function. So I can just run this code to test it. So I'll console.log. Then I'll call the function. It's called add 2 numbers, and I'll call it with some arguments. Let me say 3 and 5. So here I have called this function add 2 numbers using these 2 arguments, 3 and 5. So I expect the answer to be 3 plus 5, that is 8. So let me run the function to confirm that. Yeah, you can see here in the console, it says 8. That means that our function was fine. So that is the first thing that we need to know before solving the challenge. The other way is to create an anonymous function. So anonymous function is a function that has no name. So to create that one, after the function keyword, you can remove the name like that, and that is how the function will be. But you have to assign it to a variable. So I'll just add a variable here. I'll just call it the same name, like that. So that is how you create the anonymous function. You can see this function has no name, but we assign it to a variable. You can just call it any name. And to call this function, you'll just call this variable, like that. I think that is clear. You can also run it to confirm that it still works. So you can see it still works. And this is the other way of creating a function, and it is called the anonymous function. The other common way of declaring a function is to use the arrow syntax. And the arrow syntax is like this. You remove this function keyword and place an arrow, like that. So this is called the arrow function, or the arrow function syntax. And you can see if we run it, still works. You can see it still produces 8 as the output. Also, the good thing about this arrow syntax is that if the function body contains 1 line, you can see currently a function body contains 2 lines, but you can modify it to contain 1 line, like this. Instead of storing these results to a variable, you can just return them directly, like that. You can just return them directly like that. And you can see a function will still work. You can see it still works. And if the function is this way, it has only one line in the function body, we can omit this return keyword and also remove this curly braces like that. And you can see our function will be one line. And the function is only one line if the function body contains one statement, that is the return statement only. And this arrow syntax is the most commonly used syntax of writing a function. You can just run this to confirm it works. You can see it still works. And that is it with the arrow function syntax. The next concept that we're going to learn is called the immediately invoked function expression. You can see I've returned the code there it was initially. I didn't use the single line because I want to show you how you use IIFE easily. So IIFE in JavaScript is where you execute a function immediately after creating it. So like now here you have this function here. So you can call it immediately after creating it. You can see currently in this code we are calling this function here. So instead of calling it here, I can just remove that and I can just log the variable as is. Then I call the function here like that. But then I have to surround all this with brackets first. That is the syntax. So you can see our function ends here. Then I immediately call it. Now the output of this will be stored in this variable. And now you can see I'm just logging the variable, not the function, just the variable. And you can see if I save my code and run it, you can see it still produces 8. So this is how you use IIFE. You create a function and you immediately execute it. And you can ask yourself, like, why should we write code like this? You can see this code gives the opportunity to encapsulate a variable within a new scope. Like for example, in this code, this sum, a developer can easily see that this sum variable cannot be used anywhere outside the function body. It cannot be used anywhere outside the function body. That's the advantage of using this IIFE. I think it's clear. So let's go to the next concept, that is closures. An important topic in JavaScript is the concept of closures. That is the main thing we'll talk about in this challenge, closures. I'll try to make it as simple as possible. So let me return the code the way it was before. I think it was that way. Yeah, that way. So when a function is created, it has access to a reference to all the variables declared around it. And that is also known as its lexical environment. And the combination of the function and its environment is what is called a closure. So that was too much theory. Let's just do something. For example, this is a function here. It adds some numbers. I'll just say add numbers. I'll remove this 2 because I want to add an extra number. So allow me to remove this. So that our function will be that we add numbers. Now I want to introduce a new variable here. I'll call it C. I'll give it the value of 10. So you can see the function is here and this variable is declared outside the function. So we have said closure is the combination of the function and its environment. Environment is anything surrounding the function. Like this one is part of the environment of this function. So if you want to combine this and the function is what we call it a closure. So for example here I can say sum is equals to A plus B plus C, like that. Although C is outside the function still has access to it. I think that's clear. And you can see we're calling the function using just two arguments, 3 and 5, like we did it before. But now if we run, you can see now the value is 18 instead of 8. That means this function had access to the value C, that is 10. And it was included in the sum. And that is what we call a closure. And I think I've tried to make it as simple as possible, and I believe that you have understood. So a closure is just a combination of a function and its environment. Let us talk when we talk about When we talk about the function in function or high order function, we'll see how we can apply closures in high order functions. But this is the basic understanding of a closure. The next concept that we'll talk about is called function hoisting. And you'll also notice that we return to the initial code that we started with. And we did this for a reason. So let's learn about hoisting. So hoisting is where a function is used before it is initialized. Like you can use this function before it is even initialized. For example, I can call this one. Let me move this line of code up here. Like that. You can see now I'm calling this add numbers function. I'm calling it before even initializing the function itself. So you can see if I run this code, you can see the code works. But this hoisting does not work in many languages like Python and the rest, and also it only works with this function syntax. Where's the gotcha with hoisting? So the whole idea of hoisting is that once you run the code, once you execute this code, JavaScript bundles all the functions at the top of the file. So once you call this function here, JavaScript already assumes that this function was already declared. That's why it does not bring any error. It just runs it. But the same thing does not happen in other languages. For example, if I try to create let me just create a simple Python code. I'll just write the same thing with Python. So I can say add numbers like that. Then I can return. No, I think I missed the syntax. Should be like that. Then A and B also. That then return A plus B. Or I can just print the results. Instead of returning, I can just print them directly. A plus B, like that. So if I write that way, then I call the add numbers here with, let's say, 3 and 5, the same way that we used. And if I run this code, you can see it prints 8. This is Python. Then, but if I try to put this line on top there, you can see it also, it brings me a warning even before even I run. It just gives me a warning. And if I run, you can see it's an error. You can see there's an error there. I was trying to show you that most languages, including Python, does not support this thing called function hoisting. But JavaScript supports function hoisting. You can see now I can call this method before even I initialize it. But the gotcha was you can only do this with this function syntax. If I use the other syntax, like if I use anonymous function, like this, I think we saw this. If I use this anonymous function and if I run, you can see there's an error. You can see there's an error. It's saying that this is not declared. You can just read the error. But if you use any other function syntax instead of the basic syntax, it will bring an error. Another key concept that we learn is called the REST arguments. So REST arguments are used to access all past arguments as an array. For example, so REST argument uses the spread operator. 1, 2, 3, 3 dots, then args. That is the spread operator. So now, since these arguments will now be an array, for me to access these 3, I'll use the array way of accessing arguments. For example, to access 3, I'll use array index 0, then plus index 1, like that. Since this one, I can also log this so that you can see it's an array. So let me just log this args so that you can see it's an array. So that is how we use the REST arguments. This syntax is used to access all parameters as arguments. These parameters that are passed here, this will be accessed as an array here. So let me run this code so that you can see it. So you can see we pass 3 and 5, but it's accessed as an array of 3 and 5. So to access the first one, you'll use array index 0 to access 3, then array index 1 to access 8. And that is how you use the rest arguments. So I'll show you a place where you can learn more about the spread operator. I won't talk about this spread operator, since I can give you where you can find more about the spread operator. So if you go to the Mozilla documentation and search for spread operator, you can see it's here, spread syntax, and you can just read more about the spread syntax. And I believe also in the JavaScript, in our JavaScript course, we talked about the spread syntax. Yeah. The next concept that we learn is the concept of high order function. Let me just clear everything. So a high order function is a function that returns another function as output. For example, I can just get a simple function here, like the one we had, add numbers, like that. Or let me just call it f. Then this function f, inside it, I think I missed this syntax. Inside it, there's another function called add numbers. Then this function add numbers is just the same function that we had. It takes two parameters, then returns the sum. Returns the sum of the two parameters, like that. Then this outer function returns this other function add numbers as output, like that. So you can see you have an outer function here called f. Inside it, there's another function called add numbers that returns the sum of the two numbers that are passed. Then this outside function returns the add numbers function. So it's a function inside another function. It's called function in function. And since this function returns another function, it's called a high order function. And this is what we'll use to solve this challenge. So to execute this, let me just log. I can log what? Let me log f. But keep in mind, if you call f, let me just call it so that you can see. If you call f and run, you can see it returns this function. It returns the function, not its execution. I think it makes sense. It returns this function, but we want it to return the results of this sum here. But currently it returns this function. So for it to return, there's many ways. The first way, you can just assign it to a variable first. You can assign it to a variable, or you can assign it to a variable. I can say const add is equals to f, like that. So you call this function f and assign it to a variable add. Then this add will be this inner function here. Then you can call this inner function now add with your two arguments, like that, 3 and 5. So now if you run, it will return the value 8, not necessarily the function, because this outer function returns the inner function, then the inner function you call it again. So that's one way. The other way, you can use the IIFE that you talked about, or you can also say f, then you call f, like that. You can also write it like this. You can call f, that will return a function, then you call that function again with another arguments. Also this will work. You can just prove if you run. You can see it returns 8. But what I wanted to show you is how to use the IIFE. So instead here of returning this, you can also do that. Also, you can just do like that here. You can call the function there. There's a lot of ways that you can do. But what I wanted us to do is I wanted us to call this function immediately after creating it. So this, like we saw before, these variables, you can put them here, like that. So immediately after creating this function, I think I missed the syntax. This function should be also inside the parent, like that. Yeah. So now, after creating the function, we immediately call it, then we return it. And I think that works fine. Yeah, you can see, there's an error. Let me check the error. No, we should not return it here. We should just return it in one line here. That, and you can see it returns 8. Because you're already calling it, then you're returning there. You should return it here like one line like that. So that is how you use. That's how you create a high order function. Then the other thing we talked about closures, and I tell you that when you talk about high order function, I'll show you how you can apply closures to high order functions. Instead of taking these arguments here, these arguments can be received up here like that. Then they'll be used here. I think that is fine. So we'll not call these arguments there, but when you call this outer function is when you'll pass the two arguments like that. Now the outer function is the one that takes the two arguments. Then this inside function will access the two arguments and use them using the concept of closures. So here you have applied high order functions with closures. Now if you run this code, you can see it still works. And that is the concept of high order function. Just a function returning another function. Also you can use the spread, the rest arguments, you can also use them here like that. Like you saw, we used the array syntax, index 0 plus index 1. Also this one should work. You can see it's just fine. But the whole idea of this is just a function returning another function. And I believe you have understood that. Now that you have learned all the key concepts required to solve this challenge, we can now solve the challenge. So the challenge was to write a function that returns another function. So in short, you're supposed to create a high order function. So I'll just create my function. It's called create hello world. You have to follow the spelling. Is equals to, I'll use the anonymous function. It's equals to a function. So this function does not take any parameters, so I'll just leave it that way. Then it returns another function, so it has to return another function. I'm not given the name, so I'll use the arrow syntax, and this should return a hello world string. I missed the syntax here, so I'll just delete this one. It should be that way, like that. So yeah, I believe this one should solve. But if you look at the example, you can see that it requires when someone puts one argument, it should return the same thing. So for me to cater for these constraints for the arguments, I'll just pass the rest arguments there like that. So this means that this code can take any number of arguments, and regardless of the number of arguments, it will always return the string hello world. And that is the solution to this problem. See you in the next video. Peace out.